Welcome to our final lesson on sequences and series. We're going to talk about infinite geometric series. Our three learning targets are to understand when the sum of an infinite geometric series would converge. And convergence is when you approach a single value. Divergence is the other option, and that's when things go to positive or negative infinity. We want to use the formula we come up with to find the sum of all those infinite values, the infinite converging geometric series, a bunch of numbers you add up. And then we want to know how to solve an infinite bouncing ball problem. There's a detail in there we want to cover. So although an arithmetic series always diverges, approaches positive or negative infinity, geometric series occasionally reach a limit. And when a geometric series reaches a limit, we say it converges. The opposite of that is to diverge. So if we consider these two examples of geometric series, they're series because you're adding, they're geometric because you multiply by some common ratio to get the next value. We could just by common sense know that, so the R here is 2, that when we add a bunch of values, an infinite amount that are all positive, this thing's going to go to infinity. And we would say that this series diverges. Okay, come over here. These values are getting smaller and smaller. They're staying positive, but they're getting smaller and smaller. This R is 1/2. We would say that at some point you're adding values that are so small they don't really affect this value, and we would say you converge to a single number. Okay, not infinity or negative infinity. Let's do some practice on this. If we use our previous geometric series formula that we have used before to find these values, we know that if n is infinity, we would get something like 5 parentheses 1 minus 2 to the infinity is just infinity. 1 minus 2 is negative 1. We do 1 minus infinity, that's negative infinity. Negative infinity times 5 would be negative infinity still. And even though the negatives kind of get distracting, you almost wonder what's happening there, we get the value we assume it should be, infinity. So this formula would work. If we come down here, plugging in those same values, we see that 2/3 is the first value, positive 1/2 is the ratio. If we do the math on this, 2/3 times 1 minus 1/2 to the infinity, if you plug it in your calculator, you're going to find out it's 0. 1/2 multiplied by itself a bunch of times, you get smaller and smaller, and infinity it's 0. 1 minus 1/2 is 1/2. Let's see, so 2/3 times 1 minus 0, that's 1. So 2/3 over 1/2, that's the same as multiplying by the reciprocal. 2/3 times 2 over 1 equals 4/3. So we actually got a value, a converging value to 4/3 when you add up all these smaller and smaller numbers. In general, then, if we were to take this formula and just recognize that any ratio, common ratio of R between -1 and +1, some fraction, if you multiply it a bunch of times, you get 0. You approach 0 and get there at the end. So 1 minus 0 is just 1, and we end up with a sub 1 times 1, which is just a sub 1, and the bottom stays as 1 minus r. This is the formula we're going to use to find the sum of a geometric series where r is less than 1, bigger than -1. Sometimes you'll see this as the absolute value of r less than 1. All right. Here are a bunch of problems. I'll do the first one, and then the answers are going to be in the lesson. They're also on the next page. But for this problem, since r is 0.9, we plug in all the numbers. We're going to get this value of s equals, and we don't bother putting the subscript of infinity, the first term over 1 minus 0.9. Well, 1 minus 0.9 is 0.1. That's 1/10. 2 divided by 1/10 is the same as 2 times 10 over 1. We would get 20. So this does converge. We know that why, because r was 0.9. And then I've already solved it. So if we have convergence, we use this formula. If we don't have convergence, we just have to think a little bit about it. So I like you to look at these, see what you come up with. Here's all the answers. They're going to be online as well. If you come down here, we look at geometric series formula that we had before, the geometric series formula when r is greater than -1, less than 1. And we can start to do some word problems here. An example of converging infinite series. In this case, if you have the number 1 and you reduce it to a half, and a half to a fourth, and a fourth to an eighth, and an eighth to a 16th, and so on and so on, you can see this shape up here is getting smaller and smaller. But ultimately, we know that this area is the sum of each of these little ones, but it's 1 by 1. It should equal 1. And if we just write out the first few terms here, we would see that a half, a fourth, an eighth, and so on, and so on, and so on would give us, we know it has to equal 1, but let's test out our formula. If we try our formula here, we get S, because we're going to say there's an infinite amount of ways you can keep cutting things in half. S is going to equal our first term, which in this case was 1/2, over the common ratio, which is 1/2. Well, think about it. How many times does a half go into a half? Goes in once. Or another way is 1/2 times 2/1. You get 2/2. So the formula will get us our answer, and it's nice to see that it makes sense. Now we can trust our formula to try to do a few other problems. For each sequence, determine if the sum converges. If it does, calculate the sum. Otherwise, we just say it diverges. So for instance, this list of numbers, I'm just going to tell you, has a common ratio of 0.8. It's a number less than 1. Since that number is less than 1, we know that the formula, we can use our formula, and our formula would give us 200 divided by 1 minus 0.8. That answer is 1,000. And you can try that out. Next problem. If we look at this one, the value that gets you from 1/2 to 3/4 to 9/8, the common ratio here, these numbers are actually increasing. My r is greater than 1. Think for a moment, what do you think the answer is going to be here? Diverge or converge? And if it converges to what value? The answer is this one will diverge. Next problem we'll try. In this case, 2/3 to 1/3 to 1/6 to 1/12. But notice that these numbers are alternating positive and negative. Ultimately, our r is -1/2. That's a value that is greater than -1, less than 1. So if we did the calculation on this one, we would see you'd have 2/3 over 1 minus 1/2. 1 minus 1/2 is 1 plus 1/2. If you do the math on that, that's 4/9. Okay, try that out. For each sequence, determine if the sum converges. If it does, calculate the sum. Otherwise, write diverges. Now a little different format here. Pretty obvious in this case to tell what r is. Since r is a value greater than 1 or less than -1, we would say that these guys, all these values will add up to something that diverges. Likewise, come down here, r is pretty obviously -0.95. If we do the math on that, we plug in 1 plus 0.95 divided into -0.95. -19/39 is what we're going to get. Come down here, 2/5, a number less than 1, or between -1 and +1. Plugging in, we get 500 divided by 3. Okay, this is that bouncy ball problem we were talking about. If we talk about how far this ball travels, it makes a distance of 24 on the way down, 18 on its first bounce up, but then another 18 going down. So there's a doubling of this distance, even though at the beginning it just was 24. So if we do the sum of all the numbers going down, see these solid lines, 24, 18, and so on, we would have 24. It's going down by 25%. If you do 18 divided by 24, you get 0.75. You're losing 25%, you're keeping the 75. Likewise, starting from the bottom up, it goes 18, and then the next value would be 75% of that, and so on. So we'd get plus the distance up. So the blue represents the solid, red represents the dashed. When you add up all those values, you get 168. Okay, you should try that out. If we continue down here and we say if a bouncy ball always bounces to 80% of its previous bounce and was dropped from a height of 4 feet, so our first value instead of 24 is 4, what would that sum be? And I'd like you to try that on your own, see what you get. So we'll hit pause. All right, the number of down distances, sorry, not the number, the total distance going down is 4 divided by 1.8, sorry, 1 minus 0.8. The number going up after it's dropped one time starts at 3.2 and goes up a bunch of times, losing 20%. You're going to get 20 plus 16. The answer is 36 feet. And this will be our last problem. In a race competition, the prizes are awarded according to the following rule. First prize is a grand. Second, you get 3/4 of it, and so on and so on. Assuming there are no ties, what's the most amount of money, prize money, needed so you can pay everybody who places? And if you look at this problem here, you realize that your starting value is 1,000 and it goes down by 25%. So our R is 3/4, 1 minus 3/4. If you do the math on that, you get $4,000 in order to pay out theoretically an infinite amount of places. Likewise, if it's decided to only award prizes if they are at least down to at least 1 penny, what's the last place that gets a monetary prize? So in this case, what we're saying is, let's say you get down and you're supposed to get paid 0.9 pennies. Anybody after you doesn't get paid anything. We're just going to round up to the nearest penny. The way we'd get this answer is we start off with a sub n equals a sub 1 to the r, or times r to the n minus 1. This is our formula to find a value. We already know that we want the last value to be 1 penny. We know that the starting value is 1,000, and we are taking 3/4 of every previous prize, raising it to the value of the person who placed before you. So solving this inequality, we're going to divide by 1,000. Then we're going to quick review here. How do we undo exponents so we can get that n by itself? We have to take a logarithm. So we do the log base 10 in this case, common log 0.00001 divided by common log 3/4 is going to have to be less than n minus 1. Plugging that into the calculator and adding 1, you find out that the 41st place gets paid a penny. Okay. Just to quickly explain this then, prizes are less than a penny for anyone who places worse than 41st. That's what we're looking at there. So 41st place is the last place where you actually get paid some money. Go ahead and try some homework. We'll be ready for questions. Thanks a lot.